Hi, in this video we're going to go through some examples of exponential integrals. Now for these exercises I would not like you to use the equation that says the integral of e to the ax is e to the ax over a plus c. Don't use that. I actually want you to apply U substitution and just understand that the integral of e to the ax is related to itself, and then we'll find out how through the U substitution. Okay, so let's try to tackle this integral right here, the integral of e to the 6x dx. Maybe you're already thinking you know what the answer is, okay? But let's do this by U substitution. What are you going to use for your inside function u? You want to let u equal to, this is step 1 of U substitution, 6x, exactly. You want to let u equal to function inside the exponent. U is equal to 6x. And then as soon as you decide what you're going to use for u, then you take the derivative and get the du. That's the second half of step 1. So the derivative of 6x is just 6, and then we put the dx on that side right there. Okay? Now step 2 in a U substitution is trying to rewrite the integral in question in terms of the new variable u. Alright? So before we had e to the 6x, but now that we're letting u equal 6x, we actually have e to the u. But we're not done yet. We have to replace everything in the integral. So you can see there's a dx right here, and we're going to have to replace it with some function of du. You can see here the statement that du is equal to 6 dx's, but I only have the 1 dx, right? So what am I going to do? Divide the du by 6, exactly, because you want to match what you already have in the integral. And see right here, you just have the dx after you've taken care of the e to the u part. And so you have to figure that dx is how many du's? It's equal to 1/6 of a du. Okay, so where I see the underlined dx, I'm going to replace it with the expression du over 6. Alright, that's step 2 of U substitution, and then in step 3, we want to actually complete the integral as a function of u. So what we write right here is that in step 3, we want to just maybe make this integral a little bit easier to do by pulling out the 1 over 6. See that 1 over 6 right there? And that's the integral of e to the u du. And now that looks a little bit easier because remember, the integral of e to the u du is e to the u. It's just like how the derivative of e to the u would be e to the u. Remember, taking the derivative does not alter the function e to the x. So the answer to this is 1/6 e to the u plus c. Did I do anything? Did I forget to take the integral? No, I didn't forget, although it may look like I did. I did not forget to take the integral. It's just that the fact of the matter is the integral of e to the x dx is e to the x dx. And that is because the derivative of e to the x dx, the derivative of e to the x is e to the x. You see? So these two things are very much related right there. Taking the derivative didn't change the e to the x. Taking the integral didn't change the e to the x. But remember, when you have e to the ax, like with the 6 there for the a, that's going to come out in the wash, represented by the 1 over a term right in front of that term. Okay, so that was step 3, and then let's finish this problem off with step 4. Step 4 of a U substitution would be to take the integral that you had and then rewrite it in terms of your original function of x. So you can see in step 4 I've come to my final answer where I took this expression in step 3 and replaced the u with the original function of x, 6x. And then I'm just going to box that. That would be my answer. Don't forget the plus c when you're working with an indefinite integral like this. Then, of course, we have the secret step 5. And this secret step 5 is really, hopefully, no secret to you by now. That's the checking our work step. I still encourage you to check your work every time you've done an integral. Just quickly take the derivative of your answer in the box and make sure that when you take the derivative, you get the integrand, the expression in the integral that you were asked to find the integral of. Okay, so for my check right here, I'm going to say, what's the derivative of this thing that I found? Of course, the derivative of plus c is always 0, so that part goes away. But besides that, the 1/6 carries through, and then the derivative of e to the 6x is e to the 6x times 6. Remember times 6 because of the chain rule. So once you remember that, you see, oh yeah, that's why I divided by the a term right there, so those would cancel out, and so I get back to the original function that I was asked to integrate. Okay? So that's how you actually do the integral out using a U substitution. Let's try that again on some little more difficult examples right here. Now if you feel like you're ready, please pause the video and try both of these out by hand before you watch the solutions. I hope that you did it. That way you know if you can do it, or if you can't do it, where did you go wrong? At least you have some steps of what you were doing so you can match it with the right way and pinpoint where you're going wrong. Okay? So once again, do it now if you haven't done it. Okay, here we go with the answers. Now for this one right here, I wonder if you saw the 240 on the outside, and similarly to other integrals we've worked with, you say, I don't want to deal with that while I'm trying to integrate, so I'm just going to move that to the outside. Go ahead and move that 240 to the outside, right? And then you can see that you have to integrate this, and this is just another e to the ax type, but the a is equal to negative 0.1 in this case, okay? So to match that with the general formula we had before, the a is negative 0.1, and through a U substitution, we're going to let u equal the thing in the exponent, and then the corresponding du is going to be that value, negative 0.1 times dx. Alright, and just like in the last one here, well, for this we're going to carry the 240 to the outside, but then we have e to the u, and then dx isn't dx anymore. Really, what is dx here? Because of this relationship, when we divide out, we get du over minus 0.1 is equal to dx. Okay? So remember, on this integral, we have to replace the expression dx with something, so we better use du divided by negative 0.1. So I'm going to put du divided by negative 0.1 there. Oh, that negative 0.1. I don't want to have to deal with that either, so I'm just going to pull that to the outside. So this is going to be 240 divided by negative 0.1 times the integral of e to the u du. Almost there, we just got the one more line to do. Now 240 divided by negative 0.1 is actually equal to negative 2400. Okay, and then the integral of e to the u is e to the u, but of course remember in the final step we're going to answer as a function of x. So I'm just going to do a double step here, combining steps 3 and 4 from here, and say instead of e to the u, it's e to the negative 0.1x plus c. And that's the answer right there. And if you don't believe me, take the derivative, secret step 5, check it, and you will see that certainly the derivative of this is equal to 240 e to the negative 0.1x. Notice that the answer has a negative in front of it, because when I take the derivative of this term, there's going to be a negative 0.1 that comes down, two negatives cancel, and that's how I'll get the 240 right there. Alright, are you getting the hang of this? I hope so. This last one here we can do just like the others, except the others didn't have fractions in them, right? So I would rather not see this as a fraction. What I would prefer to do is, first of all, that 2 doesn't need to be there. We'll pull that 2 out. And second of all, 1 over e to the 4x is actually e to the minus 4x dx. Okay, so if your e to the x type term is on the bottom of a fraction, you should probably rewrite it on the top, but switch the exponent to the negative. So multiply the exponent by minus 1, and then go ahead and do it with the negative exponent. It won't be so bad. We just worked with the negative exponent right here. You see? But we haven't been working with fractional expressions, so try to rewrite the fractional expressions so that you don't have to deal with that. Okay, so now I will prefer to see the integral question as this right here, and I'll just say that's going to be 2 integral minus 4x dx. I guess I better let my u equal minus 4x, because I'm always letting my u equal the thing that's in the exponent. And then it tells me that my du is minus 4 times dx, and so when it comes time to replace my dx, I'm going to have to replace dx with du divided by minus 4. See? just like before, I have to solve out for how is dx related to du. And then I can pull that minus 4 out, so I can say that's minus 1/2 integral of e to the u du. Okay, so that's not so bad. Just separate this from the other problem there. Alright, and again, the integral of e to the u is e to the u. But to combine steps 3 and 4 together, u was minus 4x. So I might as well just put a minus 4x right there, plus c. Don't forget the plus c on indefinite integrals. And that looks fine. That looks great. One thing that I want you to notice is that each of these answers have a growth rate, which is the same growth rate as that asked in the question. Okay, so notice that when I integrate e to the 6x, I have e to the 6x times 1 over 6. When I integrate e to the minus 0.1x, I get e to the minus 0.1x, and then there's some constants that jumble around through the U substitution. This was an e to the minus 4x, and sure enough, its integral is e to the minus 4x. Its derivative has e to the minus 4x. So whenever you're working with an exponential function, keep in mind that the derivative and the integral of that exponential function will all share the same growth rate as the original function.